Thank you very much, Jehan, for organizing this, and thanks to everyone here for coming. So, Devcon2, I guess, to start off explaining what it is well, Devcon is Ethereum's annual developer conference. So a kind of event where we comprehensively talk about issues around Ethereum protocol research, Ethereum clients development, Ethereum contract programming, developing Ethereum applications. So this time around, Devcon2 was actually the third Devcon. So as the computer scientist, someone you might know, computer scientists like counting things starting from zero. So Devcon 0 was actually the sort of tiny events that we had in Berlin back in 2014. This was before the protocol even launched. And it was basically just like an internal sort of meeting of all of our developers. It was held inside of the ETHDev BV office in Berlin. And we just brought over the entire team together along with like a couple of people from Consensus and a few others, and just sort of talked about everything that we were doing. At the time, there was a lot of exciting stuff, but Ethereum was not even released yet, and so it was pretty early stage. Last year, we had Devcon 1 over in London. Let's see if I can actually move some pictures out of that. This is interesting, I can't because the internet's not working. So basically, last year we went up from having 50 people at our conference to having 300 people there. And we had this event at this rather glorious and overpriced Gibson Hall right in the middle of London City. We had, it was sponsored by Microsoft. We had 50 of our people, 50 more people from Consensus, lots of people showing off their Ethereum applications. So basically just generally talking about the Ethereum ecosystem. At the time, Ethereum had actually already existed, but even still, there was very obviously a large amount of interest there, but even still, like not nearly as much as there is now. So fast forward to this year. Last year, we had a conference in London, pretty much the heart of Europe, a fairly frequent and not particularly difficult flight away from North America, and we had 300 people. This year, we held the Devcon 2 in Shanghai, 10,000 kilometers and a visa away from almost everyone who wanted to attend. And even still, we got up from 300 attendees to 700. So the community has been growing fairly quickly. So we had 3 days, the Devcon 2 was split into 3 days. So there was the entire blockchain week, which was 6 days, but out of that week, the latter 3, like the 4th day was a demo day where there were about 36 projects that were showing off blockchain applications. And actually it was 31 projects showing off blockchain applications, and actually I counted and at least 16 of them were based on Ethereum. So then the last 2 days were kind of one challenge blockchain summits, and it was more kind of industry and applications focused. And there were a lot of interesting things that were presented there too. So Devcon itself, first day focusing on research, second day focusing on development, or like at least core development, and third day focusing on dApps and dApp development. So let's see if this works now. So from a research standpoint, I think like the Ethereum projects generally has kind of 4 major directions that we're trying to push forward on. So the first, and actually I have this slide that unfortunately can't access right now. The slide is entitled "Why Does Ethereum Suck?" And I outline a few important reasons why Ethereum sucks. Number 1, block time is 14 seconds. So if you send a transaction, people have to wait about 15 seconds for the thing to confirm. If the thing just like runs on Joe's server, then you can push that down to about 500 milliseconds. So we have something to improve here. The second thing is scalability. So even if you're okay with waiting 14 seconds, the Ethereum blockchain can still only handle about 15 transactions a second. So if you are a major multinational insurance company and you're trying to create a major multinational insurance application that will touch millions of customers, then you might want just a bit more than 15 transactions a second, you know? So, third reason why Ethereum sucks is privacy. So basically, blockchains are completely public. Every single transaction is public. Now, as those of you who have at least kind of studied internet protocols, cryptography, or computer science might know, there actually are ways to, there are lots of protocols where all the information that passes, that gets sent is complete, it can theoretically be seen by everyone, but because the data is encrypted in various ways, like the information that actually matters, like the actual content of the messages, is still obscured to everyone but the sender and the recipient. Now, with blockchains, theoretically you can do that too, but in some cases it's harder than just to do with a lot of blockchain protocols than it is with information exchange. And so far the kind of protocols and the tools to do that don't really exist in sort of that nice form. So then a kind of fourth point is security, which is basically that the protocol itself is is relatively fine. Like even with the attacks that happened during Devcon, like even there, the network kept on going the whole time, actually. So, you know, so the attacks that happened actually, they weren't even attacks on consensus, right? They were denial of service attacks. They were basically attacks that made one of the clients kind of crash when it processed some transactions because of the way it implemented it. It tried to kind of, the transaction forced it to consume kind of much more memory than it should have, and that ended up preventing those clients from processing the transaction. But fortunately, because there exist these sort of multiple implementations of Ethereum, there is completely independently written code bases that all implement the same protocol. Half the network went down, the other half of the network kept on going strong. So at the same time, you know, the incident still made us kind of look hard at how that particular client is implemented, made us look hard at kind of security procedures, emergency response procedures. Like even before the incident, there was already a security audit scheduled for that particular client. So, like for the protocol itself, things are continuing to move forward and will continue to move forward. But that's actually the piece that I'm a bit less concerned about. The piece that I'm concerned more about is actually two parts. One of them is the security of applications built on the protocol. So applications basically meaning, you know, if I write a smart contract, how, you know, the smart contract might say that it's an escrow contract, and the contract might have functions that make it look like an escrow contract. But what if somewhere on line 153 there's a piece of code that says, oh, by the way, George can take the money at any time? So there's two sub-problems there. One of them is, well, what if a developer has some bug accidentally? And the second one is, what if a developer inserts a bug maliciously? Now, in both of those cases, you know, if users are going to be able to trust the contracts that they interact with, they have to be able to actually catch those kinds of bugs and those kinds of attacks. So there's a bunch of kind of math, and there's areas like formal verification that try to catch those kinds of bugs automatically. And you know, this is one sort of major strand that we're working on. Another kind of security is user interface security, or even specifically user account management security. So in general, you know, if the way that you interact with these systems is with a private key, and if you have a private key, that then you know every single transaction you sign has to be signed, or every single transaction you send has to be signed with a private key. But what if you lose the private key? Then you lose access to your account. What if some hacker breaks into your computer and steals your private key? The hacker can now pretend to be you, steal your identity, and steal your money. So basically, you know, latency, scalability, privacy, security, like these are some of the major reasons why Ethereum sucks. Now, what is research about? Well, it's about taking all four of those directions and improving all of them. So, you know, blockchains right now don't scale. Can't we come up with blockchains that do scale? The answer is, in my opinion, yes. Blockchains right now are more slow or getting faster. Can we make them even faster? In my opinion, the answer is yes. Blockchains right now have very little privacy. Can we develop protocols that still ensure the blockchain's guarantees of process correctness, but at the same time not reveal any information that users don't want to reveal? In my opinion, the answer is yes. So research from kind of an Ethereum Foundation perspective is basically about looking at the slide, why Ethereum sucks, and seeing how much we can cross out. So This was the first day, and there were a lot of like fairly interesting things that were presented. So one of them is that as far as blockchain scalability goes, I've been working on proof of stake, which is a consensus algorithm that tries to replace like proof of work in mining. And I have a document that is called the MOVE paper, and that describes how that protocol works and how also on top of proof of stake, there's this concept of sharding, where you basically have sort of a collection of kind of fairly tightly interconnected blockchains that sort of proceed together in parallel, where you kind of only have a few computers at a time verify each one, and how you can use this kind of approach to massively increase the scalability of the blockchain. So this was part of it. Another part was on obviously privacy, on formal verification, so like on automatically verifying the contracts do what they say they do, and that have properties that they should have, and on like basically modifications to the Ethereum protocol and things that you can do on top of it. You know, for day two, for the first 2 hours, we actually had a pretty heavy security focus. So this was about secure contract programming, formal verification, and particularly about how kind of organizing developer tools, building developer tools that make it easy for developers to use these tools in order to make their contracts safe. And eventually for users to be able to actually, tools for users to be able to verify that contracts written by other people that they are asked to participate in are safe. So then after this, there were a lot of presentations on Ethereum kind of protocol development, Ethereum clients. As I mentioned earlier today, one of the exciting developments in sort of Ethereum client design is light clients. So basically being able to securely access the blockchain, but only download very small parts of it. And this is a technology that's like absolutely key for getting Ethereum properly adopted in smartphones, IoT devices, basically anything tinier than a laptop. And even on laptops, honestly, like over here, I'm running our sort of alpha light client right now because my hard drive just doesn't have enough space for the full one. So then on the third day, we focused primarily on applications. So there's actually quite a lot of things happening. Okay, I'm actually wondering why this internet service system is failing. Yeah, I'm trying here. Oh, hold on, redirecting. Ta-da.
We are holding them.
Web authentication login successful, perfect. I might actually be able to show that particular slide. Let's see if I can get into that. And also actually show some of the some of the projects that presented at Devcon2. Right. So this was the presentation, the MOVE revolution. This was the Dilbert comic that the MOVE paper is named after, in case people wants to read it and laugh. If you don't laugh, Jehan is going to charge an exit fee of 25 Hong Kong dollars.
That's not in Ether.
So there we go. So as far as kind of projects that were at DEFCON go, as far as formal verification goes, there's a few interesting ones. So there's one called Oyente. There we go. So this is from some researchers in Singapore, and they have come up with some basically automatic checking tools that check whether or not contract contains certain kinds of bugs. And well, this is actually something you can just like run on existing contracts automatically, and you can find certain kinds of issues. Like the checker is not perfect, you know, if it tells you everything's okay, it doesn't mean that everything's okay, but it can still find some things.
Can I ask a question really quick?
Yeah.
So I think that one of the things that really emerged out of the conference, and I think part of the whole program of the conference was organized around security intentionally, right? Because we've seen a lot of things happening in the community, not just Ethereum, but outside of Ethereum as well, which revolve around coins being stolen. Of course, there was the DAO hack. There have been a number of kind of quite prominent exchanges which had also been hacked. And I think from the general public standpoint, the real question is, if this, if the blockchain is supposed to provide a certain level of kind of security, why do these things keep getting hacked? What exactly is the problem here? And I guess in terms of how you were programming the actual conference itself, what types of things do you think came out of it that really address the general public's question, but then also some of the more existential questions for blockchain technology?
I think one important thing you need to understand about security is that security is never going to be 100% solved. Look, security, I think, is necessarily pretty much always going to be just a combination of heuristics, including best practices, tools, auditing, and having lots of different people audit it, using different tools, and trying to sort of inch as close as we can to kind of the ideal. But I don't think we'll ever sort of fully get there. And one of the reasons why is that basically, like, the notion of intent is fundamentally complex. So what I mean is that, I already gave this story, I think, at a previous Hong Kong meetup, even like exactly here, where I was pointing out that, like, if you create like a super intelligent AI, and if you tell the super intelligent AI cure cancer, then the first thing it's going to do is, okay, it's going to come up with like the best possible, things like chemotherapy, radiotherapy, like gene editing, whatever, and it's going to basically it'll cure like 99.99% of cancers. But then it'll realize, oh wait, there's still this 0.01% left. And how am I going to get the last 0.01%? Ooh, I got a bright idea. Let's launch a nuclear holocaust and kill everyone. Yay, no one has cancer anymore. So you might think, well, okay, I clearly programmed this thing incorrectly. Well, let's cure cancer without killing everyone. Well, okay, I'm just going to put everyone into a freezer. Not killing them, I'm just going to knock them unconscious and just conveniently never wake them up. Not the same thing. So the point is that expressing exactly what you want is hard. And in cases where the stakes are very high, this sort of divide between expressed intent and what your actual intent is can the distinction, even though it might sometimes seem small, it can get very big and very obvious. And this isn't just about AI science fiction movies. I think even in the sort of scenarios like contract programming, we've actually seen this happen. If you look at a concept like fairness, for example, we kind of understand intuitively what being fair means, but at the same time, let's try to apply fairness to a decentralized market. Well, you have to, let's see, what might it mean for something to be unfair? Well, one example of an unfair exchange might be if I make an order, and then let's say if I try and buy some Gap coin for Ether, then maybe someone will have some way to steal my Ether without giving me any Gap coin. Well, okay, maybe an exchange is fair if it has a sort of atomic property where either you get your Ether and your Gap coin, or either you lose your Ether but you get your Gap coin, or nothing happens. Well, guess what? There's another kind of attack. What if, let's say, there's an exchange where if I put an order, let's say where I say I want to buy, let's say a Gap coin for 10 Ether, and let's say if there's someone who's willing to sell for 11, let's say this exchange has some property that one particular person named, let's say Jehan Chu, has this magic ability where he can see the orders before everyone else. And so he can basically buy the Gap coin off of me at 10 and immediately turn around and sell it to the other person at 11. And no one else has this ability. Now we have an exchange that satisfies the first property. It doesn't steal money from everyone, but it still gives one guy an unfair advantage. So okay, we have to add another condition. And then we might discover some other way to cheat the system. Maybe miners can firm it, and then we have to add another condition. So defining complex concepts is not necessarily about But it's not always something that can be fully defined. Sometimes it's just a matter of like coming up with sets of conditions that kind of describe things that they can't do, and hoping that your list is complete enough. So it does sort of make the problem simpler, because instead of checking a big huge pile of code, you're checking a set of conditions. But even still, a problem remains. So that's one side. Another side is that even like looking at things like game theoretic intent of compatibility, like that's a problem that's fundamentally very hard, and like very often you just can't mathematically prove it. So like there are limits to how far kind of securing things can go, no matter what technology you use. And in some cases, it's application specific. So right now we just went through an example where we talked about decentralized markets and what it means for a decentralized market to be fair. But what if we make a DAO? What does it mean for a DAO to be fair? Well, maybe the answer is different depending on what the DAO does. What does it mean for like an auction system to be fair? The answer is like completely different there. What does it mean for some like a derivatives contract to be fair? Well, or for it to be secure? Well, there might be some other concern. So like there's the fact is, computers have a very hard time determining what the difference is between intentionally withdrawing money from a contract and exploiting a bug and unintentionally stealing money from a contract. And this is, so you can't really break, this is a gap that you can't fully bridge. But at the same time, there are lots of ways that we can improve it. So I think the best way fundamentally to think about security, I think, is actually to think about the gap between intent and what's in the Solidity code, and seeing if we can find ways to kind of bring that closer and closer and bridge it. So part of the solution to that problem is best practices. So basically just knowing here are a bunch of bad patterns, and if you use these bad patterns, you're very likely to accidentally do something very dangerous. So don't do this. And if you look at the DAO, if you look at reentrancy bugs, then we've there are a few patterns that have emerged by which you can kind of avoid reentrancy issues, this is good. So if you write your code in a way that doesn't deal with these issues, that doesn't have these bad patterns, then you don't have reentrancy attacks. There are also and the nice thing about a lot of these practices is that you can actually check for them automatically. So that's one thing that you can do. Another thing that you can do is you can actually have your code specify in different ways what it does and what it's supposed to do. So for example, if you have a contract that's like an exchange, you can actually specify, this contract is meant to, if you stick coin A into the contract, either you can get coin A out, or you lose coin A, but you can get a specified amount of coin B back. So, this is sort of like one particular atomic fairness property. And you can have automatic tools, formal verification, to automatically check and prove that a particular contract satisfies that property. Once again, not a panacea. There might be something that you forgot to check for. But at the same time, you can help improve things. So there's, third thing that you can do, you can check if who the code has been audited by, or who the code has been written by. Number 4, ideally even check, if you can avoid it, don't write code at all. Use existing pieces of code that are standardized. So I think a lot of these different things were covered. At Devcon, we talked about best practices. There were at least 3 presentations on different types of formal verification, and I think some of those presentations, some of them actually presented at Devcon 1, but there was huge progress that was made in the intervening year. Back when Inandra presented during their first year, they were just barely doing an alpha, and now they have a product that's pretty much almost ready. So it really is moving forward, but at the same time, we do need to realize that it kind of is incremental.
I think that's quite interesting. So what I'm taking away from some of that is that we kind of need to be a bit more patient in how we look at this system. And although blockchain is quite revolutionary and it offers so many amazing, magical things for society and for money and for industry, at the same time, it's still not fully baked, and it will take some time. But then I guess just to kind of flip that question around, then what can we expect from what blockchain can deliver, in the short term? Because there's so much kind of buzz, there's so much talk. Every day there's new articles. I remember the old days when we used to kind of, have a little celebration, and when blockchain or Bitcoin at the time, they didn't even say blockchain, when Bitcoin and a bank's name were included in the same sentence. Now you can't even keep up with all the banks and all the financial institutions who are doing projects actively and increasingly are moving to production for some of these systems. So I guess, what should we be able to expect? Like, what are the kind of near-term benefits coming out of DevCon that you think, we should be looking at?
I think, there were a lot of applications that presented themselves, probably both on the last day of DevCon and also, like, especially on the demo day after. And there
Any
are
particular
some,
that you thought were
I mean,
interesting?
there are some that are actually quite close to sort of the horizon. So, like, one area that seems to be moving forward very quickly is actually like identity verification. So one of them is if you look at things like Uport, and that's one example. There was also that application out of Enuma that was like basically also doing like putting a blockchain stamp for like an account and saying like that account is associated with some KYC verified identity. And there's a few other ones. Like there's also that integration that like Oracle did with the Estonian residency certificates.
Can you say a little bit about this? Because we're kind of buzzing over some of these identity, use cases and applications, but I'm not sure everybody, even understands what we're talking about,
Right.
much less understands the kind of implication of
Yeah.
identity on the blockchain. Like, what does it mean for us to have identity on the blockchain, and what is the Estonian kind of example?
So identity is a fairly broad concept. Like the way that cryptographers define identity actually is very abstract. It basically is that if there exist two messages, then message A and message B, then identity is about showing that those two messages were created by basically either the same entity or by kind of related entities that have authorized each other. So with this, like under this definition, it can actually be extremely broad because like a public key is an identity. And there actually are like people on the internet who are sort of whose only the only identity by which they're known basically is like some kind of like cryptographic identity, like it's just some kind of cryptographic public key that people know them by. And these people engage in like various like internet commerce. They sell whatever it is that they're selling. They have reputations that people trust them because they know the guy with the same public key did 1,000 other things, and the other things that a person did, were pretty legit, and he kept his word. So the 1,001st time around, we could probably trust him. So, but then that's one kind of identity. But then it gets more interesting when it's not just about sort of correlating two like cryptographic messages together. It's about correlating like a public key that signs cryptographically signed messages with facts about a person or an entity in the real world. So like a social media account is another type of identity. Another type of a phone number is to some extent an identity. Then we also talk about government issued kind of identity certificates. So basically saying that this particular identity is a citizen of a particular country, has this particular name, has this particular date of birth, can drive, can't drive, has a social security number, health insurance number, whatever. And they're like those different kinds of identity kind of have different applications attached. Like in some cases, people want to be fully anonymous. In some cases, people want to be sort of semi-anonymous, but still have reputations, and we call that pseudonymity. In some cases, they actually want most of their interactions to be able to be linkable to the sort of identity that they use for kind of everything else in the real world. And but the problem is that I think up until now, the tools for working with these kinds of identities have been fairly limited, and cryptography really offers powerful tools for verifying identities and for kind of linking behavior together, and even for using identity as a basis for reputation. But these things are things that have so far been fairly fragmented, and there haven't been sort of good very integrated systems for them. So
I mean, I think that makes sense. The ability to kind of secure your one's identity, and then in addition, the ability to kind of have that identity be interoperable between systems.
Interoperability is really key. Like I think the
Can
goal.
you actually just talk a bit about that? Because when I try to explain blockchain, one of the key things I go back to is either security or interoperability. But interoperability is something which is quite unique to the blockchain space in terms of how it's used for information, identity, etc. I mean, what does interoperability mean?
Interoperability, just to be a bit more broad than identity for a bit, interoperability in a blockchain context basically means applications can talk to each other. And we'll give a few examples. So one of them is, so let's say there are a bunch of companies right now that are issuing various kinds of tokens on Ethereum. So there's Digix, which is issuing a gold-backed token. There's about 5 projects on demo day that are doing various kinds of fiat currency-backed or fiat currency-pegged tokens. There's obviously Ether. There's various kinds of assets, so like in Augur you have Reputation, in Maker you have MKR, and like various other sort of more exotic things. But so that's like one category of thing. Now then there is a company that's building a flight insurance app. And guess what? Because of the magic of interoperability and standardization, you don't even need the flight insurance app and any of these other companies to cooperate. Like as long as this flight insurance app is designed in a way that's sort of standards compliant, you should be able to basically get flight insurance that's denominated in gold, dollars, MKR, whatever you want. And I mean, realistically, most people probably don't want an insurance package denominated in something as hyper volatile as MKR, but if we're talking about even something more mundane, like being able to choose between a US dollar backed token or a token backed by euros or backed by Hong Kong dollars or backed by Ether, that's something pretty reasonable. So that's one example. Another example is for a lot of applications, like you need to have, or you want to have some kind of identity to interact with, so some kind of identity that at least like other users sort of know you by. Even if you look at even something like like a decentralized social network, there's 3 or 5 of those kinds of projects on Ethereum. Like you actually benefit from, like it's really nice that you have a single identity and use that identity to interact with any of these projects. Like another important kind of interoperability is, even like the notion of an account, right, as like an identity. Like it's not even just about interacting with those kinds of services. Like accounts can hold digital assets. They can participate in smart contracts. They can participate in decentralized social networks. They can do lots of things. And the nice thing is that if you have one account, and if you solve the account security problem once, then you can use that account to access pretty much everything. So like this is an opportunity to get rid of the days of having a Google Authenticator, verification for like 3 of your websites, then have like a specialized card for your bank account, and then have some other method of authentication for your email, and then using your email as like a backup authentication for 25 internet forums and so forth. Like you can actually really improve the state of internet security by basically sort of splitting the problem in half. You have one group of people that focus on the security problem, and one group of people that focus on building great apps. And if both sides can at least agree to be standards compliant, then any security solution can work with any app.
I think that's a really good point, and one of the really powerful things is how kind of blockchain brings all these very disparate industries and technology stacks kind of all together in this particular layer, which ideally is very secure. I've kind of knocked you off track a bit, and I want to go back to some of the other kind of announcements that you had, or some of the other large developments that came out of Devcon. There was one in particular that I was hoping you might speak to, because it to me represented some kind of shift in how we think about the state of blockchain applications. And that was BHP Billiton, the resource company, their announcement that they're actually putting one of their systems into production. And I think what it was it's built on top of Block Apps, which is an Ethereum-based solution. And they were taking their supply chain management and actually tracking some of their core samples, their drilling samples, and using the blockchain to securely follow and ensure the sample got from A to B to C to D. What does it kind of mean for a company as large as BHP and these types of like very large blue chip industries starting to actually take blockchain seriously and rely on it for to deliver some of their core business.
I mean, I think it's incredibly positive. I think, you know, even 1 or 2 years ago, like there were definitely large companies that were excited about the technology, but going from excitement to usage, that's something completely different. And I think that right now, like maybe 1 or 2 years ago, we were on the cusp of sort of mainstream excitement, but now we're starting to be on the cusp of mainstream usage, and that's very interesting. And I think it's interesting to see how it's happening in kind of different areas at the same time. Like we're talking about various sort of banking trials, we're talking about PHP built-in, you know, tracking like mining shipments, we're talking about like chronicled tracking shoes.
Oh, the thing with Kanye.
Apparently. I mean, I don't follow celebrities much, but I do follow blockchain, so I guess Kanye convinced me to care about it slightly more.
Any other kind of applications or large announcements, especially in that kind of blue chip, you know, space? I mean, there was you had the Wanxiang announcement as well.
Yes. Let's see.
What was that about exactly?
I mean, basically, Wanxiang is putting $30 million into a kind of smart city, which is which they're going to be kind of constructing
I
fairly
think it was
close.
30 billion.
Yeah, did I say million?
Yeah.
Billion. Sorry.
30 billion. It's slightly different.
30 billion US dollars.
Correct.
There's
That's a much better city.
yes, 30 billion Hong Kong would be like, what, a house here?
Yeah, it's on the peak.
So, like, this isn't strictly a blockchain project. Like, they're going to be introducing a lot of like different kinds of new technologies. It's meant to be a sort of holistic smart city, but you know, something blockchain is definitely going to be part of the story.
Are there other industries that you think kind of came out of DevCon, or other industry announcements that came out of DevCon, or in addition, what are the industries that you know haven't really kind of showed up on the radar that you think will soon be engaging kind of blockchain? I mean, we've seen everything we've seen insurance, obviously financial systems, obviously supply chain. What are the other kind of sleepers out there?
I think after finance, one of the next frontiers is going to be the tech companies.
The tech companies, aren't they already in it?
Well, Google very slightly. Airbnb, like the acqui-hire changed it with that. Twitter, no. Facebook, no. Uber, no. So, surprisingly enough, no. And
The irony. Well, I mean, what do you think they're going to be doing with blockchain? I mean, now you have all these very, and actually, you know, here's a good question. Is it a coincidence that most of the companies that are really actively engaged in blockchain are slightly more physical in nature, or deal with kind of the movement of physical objects, and so not as much the digital side, or do you think that's just, you know, the evolution of how they're kind of taking blockchain on?
I think it could just be because for things outside of kind of tech proper, like honestly the existing technology sucks more. So it's easier for something new and shiny with blockchains built in to kind of move forward quickly. I think that's probably one part of it. Now another part is that like blockchains aren't just a kind of thing for self-contained consumer apps. They really are something holistic that could be applied just about everywhere.
What, you know, kind of going on that notion then, if blockchains could be applied to everything, kind of could be everywhere, I mean, how about the average citizen? How, like, when am I, as a user, or when is my mom going to be able to kind of start to actually encounter blockchains in her day-to-day life? I mean, are we 1 year away, 5 years away, and where do you think the kind of where do you think the first kind of engagements that average consumers are going to see, you know, in their lives?
I mean, potentially if enough websites start to see the advantage to integrate with it, even Uport a few months from now. Like that's something that seems, you know, like the social backup feature especially I think is brilliant. And like that's something.
And that's actually an interesting notion, because we're starting to talk a little bit about online, offline, and communities engaging with the technology in order to kind of secure it. Usually we think that technology secures itself, but obviously that's not always the case. What is the social backup?
So this was the feature that was like Ruben just showed about in Uport, where like basically if you lose your key, then you can sort of.
This is your identity key.
Yes. then you can kind of ask, some kind of, the majority of, some circle of your friends to basically say, this new key corresponds to that identity now. I mean, I think it's a really brilliant mechanism, like actually leveraging trust that exists, decentralized trust that exists in the real world in order to solve, sort of key security problems, in a way that doesn't reintroduce centralized parties. Another company that I've already consistently praised for doing something slightly similar is Autonomous in Singapore. They have this mechanism where if you lose your key, they sort of mathematically split it up, and they keep one copy themselves, and they give 2 copies to 2 law firms. So you need sort of 2 of those companies to collude in order to bring the key back together. So, once again, a really interesting mechanism, I think.
Any other kind of consumer-facing applications that you think are going to be coming up in the next couple of years, where people will actually start to reap the harvest of blockchain that's been promised for so many years?
I think, on the identity side, I think the case is fairly clear. On the kind of blockchain payment/finance side, I think one of the challenges is basically that Ethereum has the same problem as Bitcoin, which is, number one, moving in and out is hard, and number 2, price volatility. Like, it actually is really nice to be able to, if we could just have like things that act like dollars or euros or yen or yuan on the blockchain. But right now, instead, we have these like weird hyper-volatile crypto tokens that appear where Ether apparently moved up like 2% right between the time that I was coming into Hong Kong and this meetup. Whereas if a fiat currency moves by 2%, you have like mainstream news articles about it. So it's that like having something that actually is stable, and where you can if Aaron is buying a phone from me for 0.06 coins, that he can actually be sure that the coins will have the same value between the time that he sends them in and the time that once he receives the phone that I get them out. So, but once that problem is solved, I think that's also going to push sort of the frontiers forward a bit. And at that point, it's basically just like a matter of reducing friction. Like how can we make it sort of fairly seamless to move between things that are blockchain based and WeChat payments, PayPal, or whatever else sort of in the traditional world people want to use. I think that's one part, and then the other part is obviously security. And security, I think, includes like the security of these actual systems themselves. So like I think it would be terrible if customers start like really trusting like one particular instance of dollars on the blockchain, and it turns out those dollars are backed by dollars in some shady bank account, and the company disappears, and its founders would go on a really expensive vacation, and it's a Panama. So it's like we want to make sure that these services are services that we can trust. And like in some cases, it might be the traditional sort of social/reputational/regulatory trust model. In some cases, with blockchains, we're hoping to really introduce and get as much as we can out of this kind of more cryptographic, sort of backed by math trust model. And in some cases, it's going to have to be a combination of both.
Sure. I have a couple more questions, and then we'll actually open it up to the floor to ask their questions. One of the things we talked about earlier today was this notion of kind of token economies. And again, one of the things I noticed at Devcon is that there were so many, I guess we've been calling them in the community ICOs, which stands for Initial Coin Offering. But there was actually a really great talk by a gentleman from Point Center, a lobbying/policy think tank in Washington, D.C., that we should no longer call them ICOs because it's tripping up with the regulators too much. We should call them token launches. So it seems like there are more token launches going on, and these token launches are raising more and more money. I think we all saw with this DAO raise, which was $150 million US, which is really unprecedented. That the kind of bar for what's possible to crowdfund in the crypto world is quite high. And I think just earlier this week we saw even a much smaller one called First Blood, which had raised about $5.5 million US for their effort in 3.5 minutes, which is really, once again, really unprecedented what's possible. I think we're going to be seeing more of these. What do you think of these notions of token economies? Where do you think the kind of mechanisms are going? And again, like how should the public, both individual citizens as well as kind of companies, start to think about these mechanisms and these tokens? How they'll be used? How they'll be how they'll be interacting with them? Is it just about raising money, or are there other types of uses for them?
Yeah, so I mean, it's clear that there are a lot of projects that are trying to use various kinds of tokens and sales in order to fund themselves. So, but and you know, to some degree, this makes sense because there were a number of sales that were very successful. So you know, Ethereum itself got about $18 million of Bitcoin. Then if you look at the Digix DAO got about 5 million. Then First Blood got about another like 5.5 million. So there are a lot of projects that are seeing this is you can get money very seemingly quite easily this way, and they're looking at it as a model. And I personally really strongly believe that both crowd sales and token and sort of token incentivization in general is like really fundamentally a good thing, and it would be a terrible tragedy if we were to sort of try to like move away from that model entirely. And the reason why I say that is that historically speaking, like base level protocols have always been a fairly underfunded public good. So if you look at
What would be an example of that? I mean,
well, I'll give a very specific example. So in 2014, there was a major security bug. This was called hard-booted that affected like a really large number of websites. And what ended up happening was that there was a bug in the OpenSSL library. So this was like a really low-level library that a lot of projects ended up using. And one of the things that was discovered in the aftermath was that even though there were billion-dollar corporations that were relying on this library, like the amount of funding that was going into actual ongoing development was like somewhere in the thousands or tens of thousands of dollars. So basically, there were everyone depended on it, but no single person felt that there would be much of a difference between they themselves contributing and themselves not contributing. And so nobody paid money, and so the thing just ended up being totally underfunded given its awful importance. So what we see though is that in crypto, with these kinds of token sales, for the first time we're seeing that flipped on its head. We're actually seeing low-level protocols themselves being the direct object of monetization and of the sort of highly structured and incentivized approach to development. And that's something that's really powerful. And now, this isn't going to solve every public goods issue. You're not going to be able to crowdfund the solution to world hunger in Africa. But it can.
maybe you could actually.
But you get the point.
Who knows? All right, I'm sorry. Go ahead.
No, go ahead. Not in the next 5 years. But at the same time, we can't solve this one piece of this one very real problem that's affecting the software industry. But there are challenges. So one problem is that there are these sort of various sort of incentive flaws where it's very easy to use this kind of approach to get a lot of money in the short term, but then you don't really have much incentive to use the money to actually push the project forward. Another kind of problem is just generally in assessing quality. And this is a problem where honestly, all of the mechanisms that society currently has at its hands is pretty bad at them, because individuals often have a hard time figuring out whether or not a particular project is good quality or bad quality. We can try reaching out to the SEC for help, but honestly this is about the kind of expertise that you need here is cryptographic expertise, not expertise in filling out bureaucratic and tax forms. So it's we can try and look at even various kinds of sort of social and community verification, but then you really needs to make sure that those kinds of things are often subject to manipulation. The fact is that yes, you can pay $2,000 for people to write very good comments about you on your internet forums. So, and there is even an industry of people doing that on Bitcoin Talk. So, trying to figure out a way of sort of sorting the good from the bad, that's another challenge. So, the third challenge is also exactly what mechanism actually gets used in figuring out actually doing the crowd sale. What's the economic model? And there's a few different dimensions to this. So one dimension is how do you sell it? What's the price? What's the duration? What are the is there a cap? What are the conditions? There are good ways of doing it, and there are bad ways of doing it. So one thing that's been popular recently is this approach of setting a very low cap and trying to hit the cap, get people to rush in and hit the cap very quickly. problem is that very often, what this ends up leading to is like only 100 or 200 people participated, and then like everyone else who didn't get in time feels that the whole thing was like unfair, and there were like, a few people that were able to get an advantage. So there are other approaches, but some other approaches, like they end up getting like too much interest coming in very early, and then not enough interest coming in later. So there are like that's something that I think you can't really figure out now. We just have to like try lots of different approaches incrementally, see what works and what doesn't. Another important dimension of the economic model is what does a token do? Like a lot of people do have this sort of idea that, oh, you can create a token, and if you like somehow sort of wriggle the token into the dApp in some way, then it's going to have a value. But in reality, that's not enough. Like if the thing is that like one question I think you have to ask is, if you are making a dApp and your dApp has some token that you're crowd selling, would this dApp work? Does having a separate token actually help the dApp? Would the dApp not be replaceable by a dApp that does exactly the same thing, but instead of that token, it just uses Ether? A lot of the time, the answer is yes. And for those cases, you don't want a crowd, you don't really need a token, you just use Ether. And in some cases, the answer is no, and a token actually does make sense. So one specific example where I think a token does make sense is something like Augur, where Augur is a prediction market where people can kind of bet on events. But at the same time, for people, if you want to be able to bet on events, you need to have some mechanism for later on kind of determining what actually took place. Did Donald Trump win the election, or did Hillary Clinton win the election? Or did everyone suddenly decide to, I don't know, write in
Vote for Gary Johnson.
Yeah, or I was about to come up with the name of some shady Bitcoin person off somewhere in Florida, but I couldn't come up with a name in time. Well, you need some way of sort of putting into the blockchain whether or not the events took place. So the approach that Augur has is basically there's this token that's called rep, and rep holders basically vote on what happened. And the approach is interesting because there's this mechanism that says that if you agree with the majority, you get rewarded, but if you disagree with the majority, then you get penalized. And so the sort of economic principle here is that if you were to if you think that everyone else is honest, then you also have the incentive to be honest yourself because you want to agree with the majority. And so it's a sort of nice self-enforcing equilibrium, which is sort of game theoretically very cool. But the thing is, this kind of thing would not work very well with Ether, because if you used Ether, then if there was 10,000 Ether voting, then someone some very evil person would come in with 20,000 Ether and just outvote everyone else. So it would just be too easy to just sort of break into the system and wreck it. Whereas with Rep, because you have an independent token, you can do things for an attacker to do that. First of all, they'd have to buy up half the Rep in existence, which would itself push the price way up. Second of all, basically what would happen is that after there would be a vote, and the person who bought up all the Rep would win the vote. But at the same time, everyone who lost that particular vote, because they were actually voting on the right answer, Augur has this mechanism where they can kind of split off from Augur, and they can kind of basically sort of create a new Augur that just has them being the Rep holders. And the market would very clearly see, okay, guys, this was an attack, and so this particular version of Augur where the attacker has 80% of the Rep is worthless, and the price of that drops to 0, and there's this new sort of splinter Rep that has the honest people in it, and so everyone's going to trust that instead. So the point here is that you have this really cool game theoretic mechanism that can give sort of right answers for questions about the real world, at least hopefully, but it relies on an independent token to work.
So I think what you're saying is we'll see a lot more of these tokens which kind of perform and function in different ways.
Exactly,
To
we're
create liquidity in the
different
system
ways.
in a way.
They're going to have different roles, but I think the point is that you need your token to actually have value.
Cool.
And I can also say one more thing, which is that sometimes the thing that you're crowd selling might not even need to be a token. So one example is, let's suppose he wants to build a domain name system on Ethereum. Instead of crowd selling a token, you might want to just directly crowd sell, let's say, the one-letter domain names. If you're crowd selling, .eth, or being able to make .eth domains inside of Mist, then people might be willing to pay a lot of money to be able to have x.eth or q.eth. There's a crowd selling opportunity. Another example, let's say you have a decentralized social network. Well, why not crowd sell future advertising space. And, so there are lots of opportunities like that might be underexplored as well.
Okay. So I think at this point we're kind of getting to the end. Are there any other last kind of like announcements or any last takeaways from DevCon that you wanted to share? Or should we just go to the crowd and ask them what they want to know?
Yeah, what does the crowd want to know?
Questions? Go ahead. You tell me and I'll repeat it.
Yeah, Microsoft used Devcon to announce Bletchley. What's your view on it for consortiums, the blending of blockchain with more traditional identity, etc., creation of their cryptics for oracles, etc.? What's your view on that announcement?
So the question was, Microsoft made a big announcement at DevCon announcing their Bletchley project, which includes an ecosystem for creating what they call cryptlets, which, as I understand, are basically kind of modular applications which sit on top of the blockchain and try to perform certain basic functions that I guess they think that everybody will want to use, things like identity, things like that.
Yeah, and cryptos are meant to be this kind of combination of oracles using what was trusted hardware components to make them more reliable. So I think it's, first of all, definitely very supportive of these kinds of efforts to try to make blockchain sort of code more accessible in an enterprise context. And like something like Bletchley is definitely kind of very helpful there. And I think there definitely is this kind of gap in between how like the technology as it exists now and the technology in terms of what enterprises want out of it. And having it sort of packaged up, having business-friendly APIs and so forth is very important. And like cryptlets are, in general, the problem of kind of connecting blockchains to the real world. Like this sort of decentralized Augur Oracle is one approach, and the fact that the Augur developers spent like a year coming up with this, like really, and it wasn't just them; it was also building off of previous work by Paul Stortz. But spending like over a year coming up with this mechanism for sort of bringing information from the real world into the blockchain in a trustworthy way just shows how important the problem is. And here, we have kind of more direct approaches that try to sort of bridge together with existing APIs, and like that's also definitely an important piece of the puzzle.
Great, thank you. Hinder.
Questions about the MOVE paper. A two-part question. First, what were the more interesting questions about that arose in Shanghai? And the second part is, when is the ETA on version 4?
So the question was the MOVE paper, and the MOVE paper was, I guess, a paper that Vitalik issued an updated version of at DevCon, which expressed I guess the more complete version of the switch from proof of work to proof of stake in Casper. Is that right? And then the question was, I guess, the ETA
Of the next version of the paper.
of the next version of the paper.
I think like the current version is probably roughly where I want it to be at the moment. So we're at the third version right now, and it's been translated into Chinese, and it's actually even been been translated into French at this point. But I think that the thing that we're focusing on the kind of MOVE side right now is going from the paper and actually implementing it in a piece of proof of concept code. So we have a couple of developers that are working on the Python side in order to do that.
Go ahead, Jeff.
First of all, comment about Africa, since I'm actually using blockchain with Africa trade. The problem hunger in Africa has been solved. The problem in Africa is how to move 1.5 billion people into the middle class status of living without destroying the planet. So don't worry about solving hunger. That problem's already been solved. So one of the, I want to throw out a thesis, and I want to see how you react to it.
Although I'm going to ask you to ask a short question, otherwise I won't be able to repeat it.
The question is, it seems to me that we're not going to see any blockchain applications in the next 2 or 3 years unless we layer blockchain on top of existing legal, regulatory, or human systems. That pure crypto won't work for most usable apps in the near term. First of all, do you agree or disagree with that? If you agree with that, then how do we get the lawyers involved?
Yeah, in general, I'm inclined to agree that blockchains definitely needs to kind of interface with the real world. I would say it's very application specific. Like there are, if you look at identity versus looking at financial applications versus looking at something like the supply chain applications, like there are different application specific problems, and I think the answer is going to be different for in each one of those areas. I don't think there's like any one sort of silver bullet that I can kind of provide. I'd also say lawyers are not even the only sort of category of existing sort of professional that matters. I think if we even if we look at like the example after finance that I gave was just tech companies. Like there are even like people who are working on traditional in technology and things like existing social networks, identity, all these problems that already existed needs to actually interface with kind of the people who are approaching it from the blockchain side and actually come up with something that's both has what the nice security problems that we're trying to get and is actually usable. On the finance side, there's a lot of kind of people from the financial industry who are coming in who are developing various kinds of like financial applications for things like clearing and settlement. Like there's a project called the Utility Settlement Coin that Clearmatics has been doing out of the UK, which is basically creating a kind of digital token that can be used as collateral for financial contracts inside of an Ethereum consortium network. And this token is sort of almost directly backed by a central bank money. So this is actually a technical innovation and a regulatory innovation at the same time, which I think is wonderful.
Okay. Sam.
Yeah, so I just wanted to build on that question, if I may. I guess the skeptics and all the pragmatists would say, and there's a lot of noise around blockchain, as you've alluded to, they would say that at the moment, blockchain is a little bit of a solution trying to find a problem. So we spend a lot of time talking with clients in the consulting world about, let's just start with what the problem or opportunities you're looking at, and then we can talk about later on whether or not blockchain is a potential solution. But clearly it is lending itself, more and more going on. I'm just interested, Vitalik, in your view on the kind of ingredients for success to develop use cases that are going to be adoptable by lots of interested parties.
So I guess the question is, what are the ingredients to success for developing strong use cases that will actually see the light of day and perhaps be adopted and successfully kind of implemented in kind of larger companies?
I think right now, what we're moving toward adoption, actually on a surprisingly sort of even schedule across lots of different industries. Like, so right now, we have identity, there's supply chain, there's finance, and those are probably like three kind of vectors that are actually pretty close to even going head to head against each other. So if you look at, Uport, BHP Billiton thing, and even like the various like tokens and like financial contracts that are on the Ethereum blockchain. So I think it's from that standpoint, it's fairly even. But then the other question you can ask is like inside of each industry, kind of where is it going to happen, and even what are the signs that there is an opportunity, and what are the signs that an opportunity actually can be successfully exploited. I mean, there's also the divide of working through an existing large corporation and a startup, and there's a lot of things like partnerships that are in between. So it's from that side, actually I think the in-between model is even the one that's been the most successful right now. If you look at even like the BHP Billiton thing, biggest mining company in the world together with Consensus. If you look at Uport, it's Consensus. They're looking at working with Ubuntu, working with all these other established entities. Utility Settlement Coin, Clearmatics, working with like five or even more major banks. So it's that's, I think, in general a fairly good model, and on other industries it may even be one that could be replicated.
Maybe one last question, Aaron?
At Devcon, you and Vlad Zamfir spoke on your approaches to proof of stake. Could you differentiate your approaches?
So at Devcon, you and Vlad Zamfir had two different approaches to proof of stake. Can you kind of characterize those?
So my approach to proof of stake, well, if you want to learn about the whole thing, it's in this move paper. But in general, I have one particular sort of strategy which is fairly sort of incremental. It's sort of moving from starting proof of work, seeing what are some fairly sort of minimal changes that we can make to push it to proof of stake, then add one property, then add scalability, then add more properties on top of it. Vlad is, I think, taking a kind of much more sort of fundamental and kind of restart from scratch approach. So, like, both categories, I think, have their advantages. Like, I think realistically, if we want the thing to actually get developed, then in a very short time or short or reasonable time frame, then an approach that tries to sort of start slow and start modest is by far the more realistic one. But at the same time, you know, like, even my own personal approaches over the last couple of years, like, there are a lot of sort of Vladian ideas that have flowed into them, you know, over like once every few months. Like, even here, you know, I talk about fork choice rule as value at loss. That was a Vlad idea. In general, the emphasis on economic incentive analysis is another Vlad idea. The emphasis on using coalition economics to make sure that, like, even coalitions of, you know, more than 51% of the stakeholders don't have the incentive to act badly. That's another Vlad idea. So, in general, like, there are a lot. Like, our research process in general tends to, I think, hit at different parts of the pipeline at the same time. Look, there's part of the pipeline that's closer to developing. There's part of the pipeline that's more theoretical. There's part of the pipeline that's taking the theoretical and trying to refine it more. There's part that's looking at, like, simulations and then realizing that they reveal a problem with the theoretical and they need to go back to it and improve it. So I think the two are really complementary.
Okay, I think that's kind of all the time we have for now. Of course, Vitalik will be here for a little bit. I just want to say thank you for once again taking time to kind of share all of your thoughts and takeaways from DevCon. So thank you. I'd like to hand over to Simon.
Well, only just to say, ladies and gentlemen, thank you very much on behalf of KPMG for coming this evening. It would be remiss of us to not also thank Jehan for kindly arranging this evening on behalf of the Ethereum Meetup community. So, Jehan, thank you very much to you as well. I was just reflecting with Vitalik a little bit earlier on the June session we had, which I think was entitled The Road Ahead. And to Vitalik's credit and foresight, his opening comments reflected on the fact that the road ahead could well be a bumpy one. And for those who know their dates and were here last time, 3 days later, the Devcon came and went. Tonight's discussion has been a little bit more reflective on the past in terms of the Devcon2 conference in Shanghai. So I'm really hoping that in 3 days' time we're not going to have a similar experience. But Vitalik, thank you very much again. Fantastic and very interesting always to spend some time with you. So thanks everybody. Enjoy the refreshments.